So this question asks us, how many moles of magnesium sulfate do 5.6 times 10 to the 23 molecules make up? So again, what we're going to do, when you see the word molecules here, you will be using Avogadro's number at some point in time. So it is important to recognize and know that 1 mole of magnesium sulfate is equal to 6.02 times 10 to the 23. Now, the question tells us, though, that we have 5.6 times 10 to the 23 molecules. So if 1 mole is equal to 6.02 times 10 to the 23, our answer should be actually less than 1. So what we're going to do is we're going to use this this equation, this equalness to figure out, not equalness, but this unit conversion to figure out exactly how many moles we have. So we have 1 mole over 6.02 times 10 to the 23, and we're going to multiply that by 5.6 times 10 to the 23 over our unknown. Okay, so we're just going to multiply our numerators together and our denominators together. So 1 mole multiplied by 5.6 times 10 to the 23 will give us 5.6 times 10 to the 23, and you can have mole there for now. Okay, and then we have 6.02 times 10 to the 23 multiplied by our unknown, or something that's not there. So we're still going to have that 6.02 times 10 to the 23x, or our unknown. Okay, so now what we're going to do is we're actually going to divide 5.6 times 10 to the 23 by our 6.02 times 10 to the 23 as well. And for this number, so again in your calculator, if you can go ahead and put 5.6 times 10 to the exponent 23 in your calculator, but when you go to divide, make sure you put brackets first, because the calculator will then recognize your whole 6.02 times 10 to the 23. If you do not put brackets in, it'll just divide by 6.02. and then multiply it later by 10 to the 23, which is not what you want it to do. So I'm going to go ahead and put 6.02 times 10 to the 23, and I get an answer of 0.930 grams. Okay, or sorry, not grams, moles, because we are working in moles. Okay, so in terms of our significant digits here, the one that has the least amount would be your 5.6, so we're going to have 2 significant figures in our question, or our answer, so 0.93 moles is our answer. And the question to ask yourself is, does this make sense to what the question is asking? We're very close. Our exponents are exactly the same, 10 to the 23, for both our mole and what's given to you in the question. So you just have to focus on the decimal aspect, the numerical aspect, of what that exponent is, which is that 5.6 compared to 6.02. They're very close. And 1 mole is equal to 6.02. We don't have 6.02, we only have 5.6, so we're just shy of a mole, so it does make sense that we would have 0.93 moles. So I hope this helps. Please let me know if there's any clarification that needs to happen. Thank you.